William Harvey, an English physician of the 17th century, stands as one of the towering figures in the history of science, his intellectual legacy encapsulated in three seminal works: Exercitatio Anatomica de Motu Cordis et Sanguinis in Animalibus, Exercitations de Generatione Animalium, and Exercitatio Anatomica de Circulation Sanguinis. These texts, born from decades of painstaking observation and experimentation, not only redefined the understanding of human physiology and the origins of life, but also marked a pivotal shift in the practice of science itself. Harvey's career unfolded against the backdrop of a Europe steeped in tradition, where the ancient teachings of Galen and Aristotle held sway over medical and philosophical thought. His willingness to challenge these authorities, armed with little more than a scalpel, a keen eye, and an unrelenting curiosity, established him as a trailblazer, whose ideas reverberated far beyond his lifetime, influencing the trajectory of medicine, biology, and the broader scientific revolution. Harvey's first and most transformative contribution, De Motu Cordis, published in 1628, introduced the revolutionary concept of blood circulation, a discovery that shattered over a millennium of Galenic orthodoxy. At the time, the prevailing view held that blood was produced continuously in the liver from ingested food, flowed through the veins to nourish the body's tissues, and was subsequently consumed or dissipated. The heart, according to Galen, served merely to heat this blood, while a supposed network of invisible pores in the ventricular septum allowed blood to pass from the right to the left side. Harvey, trained at Cambridge and the University of Padua under anatomists like Hieronymus Fabricius, began to question these assumptions through his own dissections of humans and animals, ranging from mammals to birds to cold-blooded creatures like frogs. His observations revealed a different story. The heart was not a passive furnace but a muscular pump, contracting to expel blood and relaxing to refill. In a stroke of brilliance, Harvey employed quantitative reasoning to bolster his case. He calculated that the heart, beating roughly 72 times per minute and expelling a modest volume of blood per beat, would pump thousands of ounces in a single day, far more than the body could possibly generate or use up under Galen's model. This led him to the inescapable conclusion that blood must circulate, traveling from the heart through arteries, nourishing the body, and returning via veins in a closed loop. The brilliance of De Motu Cordis lies not only in its central thesis but in the meticulous evidence Harvey marshaled to support it. He described the unidirectional flow enforced by venous valves, demonstrating through ligature experiments how blood pools behind these structures when veins are compressed. He traced the pulmonary circuit, showing how blood moves from the right ventricle through the lungs to the left atrium, debunking the septal pore myth with anatomical precision. His vivisection studies, conducted on living animals, revealed the heart's dynamic action, its chambers filling and emptying in a rhythm that propelled blood outward rather than merely warming it. The book's 17 chapters, though concise, are a masterclass in logical progression, moving from the heart's anatomy to its motion, from pulmonary transit to systemic flow, and culminating in a refutation of Galenic errors. Yet its reception was far from unanimous. Traditionalists, wedded 2 centuries of doctrine, dismissed Harvey's ideas as heretical, and his medical practice reportedly suffered as patients shunned the radical physician. Over time, however, the weight of his evidence prevailed, especially after Marcello Malpighi's discovery of capillaries provided the microscopic link Harvey's naked eye couldn't see, cementing De Motu Cordis as a cornerstone of modern physiology. 2 decades later, Harvey turned his gaze to the mysteries of life's beginnings with Exercitations de Generatione Animalium, published in 1651. This sprawling, introspective work, spanning 72 exercises, shifted his focus from the mechanics of circulation to the processes of reproduction and embryology, reflecting both his scientific rigor and his philosophical wonder. In the 17th century, theories of generation were a chaotic blend of Aristotelian philosophy, religious creationism, and emerging preformationist ideas suggesting that organisms existed fully formed in miniature within sperm or eggs. Harvey, drawing years of education and observation, sought a more grounded explanation. His central claim, encapsulated in the phrase ex ovo omnia, translated to all things from an egg, posited that all animal life originates from an egg-like structure, a bold attempt to unify the reproductive processes of oviparous, egg-laying, and viviparous, live-bearing species. For birds, this was the literal egg, which he studied through daily incubations of hen eggs, meticulously documenting the embryo's development from a tiny white spot, the blastoderm, on the yolk to a beating heart by day 3 and a fully formed chick over weeks. For mammals, he hypothesized an analogous starting point, though the mammalian ovum eluded him without the aid of a microscope. Degeneration is rich with detail, drawn from Harvey's dissections of deer uteri during his tenure as physician to King Charles I, who granted him access to royal hunting grounds. He described the embryo's transformation from an indistinct mass to a recognizable fetus, marveling at the parallels with chick development and reinforcing his belief in a universal generative process. Harvey championed epigenesis, the idea that organisms develop progressively from simple to complex forms, over preformationism, arguing that his observations showed no preformed parts, but rather a gradual unfolding of structure. His work also grappled with the roles of male and female contributions, rejecting Aristotle's view of semen as the sole active agent and proposing instead that it acts as a contagion or catalyst triggering development in the female's material, though he couldn't pinpoint the mechanism. Sperm and ova as cells were unknown. Less immediately disruptive than Motu Cordis, degeneration faced fewer critics, partly because it aligned with philosophical traditions, but its influence grew over time. Later embryologists like Caspar Friedrich Wolff built on Harvey's epigenesis, and the eventual discovery of gametes validated his intuitions, securing the work's place as a foundational text in developmental biology. Harvey's final major contribution, De Circulatione Sanguinis, emerged as a spirited defense of his circulation theory amid growing skepticism from the medical establishment. Written as 2 letters to Jean Riolan the Younger, a leading French anatomist and critic, this work responded to challenges that had arisen since De Motu Cordis. Riolan, among others, argued that circulation was incomplete, that the liver remained central to blood production, and that Harvey's ideas undermined clinical practices like bloodletting. Harvey, now in his 70s and weathered by the English Civil War, which had destroyed much of his earlier research, reasserted his thesis with characteristic clarity. He reiterated the heart's role as a pump, supported by new dissection evidence like the rapid emptying of arteries post-mortem, and reinforced the venous valve's function through ligature experiments. Addressing Riolan's clinical concerns, he suggested that circulation could refine rather than abolish bloodletting, proposing targeted vein selection based on flow patterns, a pragmatic olive branch to traditionalists. The second letter delved deeper into pulmonary circulation, countering Riolan's doubts with detailed anatomical observations of the pulmonary artery and vein, and tackled broader philosophical objections by framing circulation as nature's efficient design. Harvey also briefly addressed lesser critics like Caspar Hofmann, dismissing their objections as failures to engage with his evidence. Though shorter and less original than his earlier works, De Circulatione Sanguinis was a critical bridge, sustaining circulation's credibility during a period of personal hardship and intellectual resistance. Published amid England's turmoil, it didn't silence detractors immediately. Riolan responded with his own treatise, but it kept the conversation alive, paving the way for broader acceptance after Harvey's death in 1657, particularly with the capillary discovery that completed his model. The collective importance of Harvey's works transcends their individual discoveries, lying as much in their method as their conclusions. In an era dominated by speculative philosophy and blind adherence to ancient texts, Harvey pioneered an empirical approach, dissection, vivisection, quantitative analysis, that demanded evidence over authority. De Motu Cordis revolutionized medicine by providing a mechanistic view of the body, enabling advancements in surgery, diagnostics, and therapeutics that continue to shape healthcare today. Generatione Animalium, though constrained by its time, anticipated the dynamic processes of embryology later elucidated by cellular and genetic science, offering a vision of life's continuity across species. De Circulatione Sanguinis ensured that his circulatory breakthrough endured scrutiny, cementing its place in the scientific canon. Together, these works embody the scientific revolution's ethos, a relentless pursuit of truth through observation, a willingness to challenge dogma, and a humility before nature's complexity. Harvey's personal journey amplifies his contribution's significance. He faced professional setbacks, patients fleeing his practice, manuscripts lost to fire, and lived through political upheaval as a royalist in a fracturing England. Yet his persistence yielded ideas that outlasted the chaos. His influence rippled through the Enlightenment, and his emphasis on experimentation set a standard for future generations. Beyond science, Harvey's works reflect a profound human endeavor to understand the body's inner workings and life's origins not through divine fiat or ancient decree, but through the tangible, testable reality of the natural world. His legacy is not just the circulation of blood or the egg as life's seed, but the courage to see anew, a gift that transformed knowledge and endures as a testament to the power of inquiry. Thank you for watching. Be sure to hit the like and subscribe button and stay tuned for more content on the philosophy series.